Hello and thanks for watching. Over the next few minutes, I'll be showing you how to build a dynamic mortgage amortization table from scratch. Now, this exercise I did 5 years ago, and the quality of the video is not great. There are quite a few features in that module that I wish I had included, and so I thought, why not redo this? And so we'll be building this module. Now you can download the completed module as well as the template file if you want to follow along from our website. The module is quite simple. It's one tab. You can pull it into your own real estate financial model and use it for whatever purposes you may have for it. But today I'll be showing you then how to build this module. So let's go ahead and get started. Now you'll notice in the template I already included our labels, headers, as well as formatting, and that will just speed along this process. So let's get started. Original loan balance. This is the loan balance as of the start of period 1 or the end of period 0. Then we have interest rate. This is an annual rate. We have amortization in years. This is the number of years, if the loan is fully amortizing, that it will take for the loan to get from 15 million to 0. So here we'll say 30 years. Now you'll notice that I've appended a label inside the cell. So if we look up at the top, this is a 30. So Excel views this as a value, but I included that years label in there. And to do that, just hit Control-1. That will open up your Format Cells dialog box. And then under Custom Cell Formatting, you can enter a 0, and that denotes a numeric value. And then inside quotation marks, anything inside quotation marks will become a label within the cell. So here I labeled it years, and the result is Excel views this as 30, but visually it's 30 years. And then periods. Now this is unique to this amortization table. Generally, you're looking at 12 periods in a year, but perhaps you have quarterly payments or maybe annual payments. We can change the number of periods per year, and that will adjust the frequency of those payments. Next, we have loan term. So while this may amortize over 30 years, the loan is due and payable at the end of the loan term. At which point there's a balloon balance, meaning a balance above 0 that the borrower must pay to the lender at that point. That's that loan maturity. So in this case, I'll just say 10 years. A 10-year term with a 30-year amortization is a fairly common structure in commercial real estate loans. Then we have interest-only periods. Again, a common feature in commercial real estate loans. You may have a certain number of years where the payment is interest only. No principal is going to pay down the loan balance in any given period. So here I'm going to say 0. Actually, let's put 3. And what we'll see then is there will be no principal paid towards the loan balance in the first 3 years. And then in every period beyond that, it will begin to amortize for the preceding, I guess in this case, 30 years beyond that 3-year IO period. So technically it would take 33 years to pay this loan off. Next we have payment. This is our first formula. And that's fairly simple, right? It is equal to the loan amount times the rate divided by the number of periods in the year, right? Because there are 12 payments in every year. We take basically the loan amount times the rate that gets us the annual interest rate or the annual payment, and then we divide that by the number of periods to get us to a interest-only payment of $62,500. Next, we'll calculate the amortizing payment. Now, Excel has a function called the PMT, and that calculates for you an amortizing payment. We go equals, and now I'm going to set this to negative, and the reason is because it will convert what it would otherwise be a negative value to a positive. So I do negative PMT, open parentheses, then asks for the rate. Well, the rate is our annual rate divided by the number of periods in the year, comma, And then it asks for the NPER. That is the number of payments for the loan to fully amortize, or in otherwise amortization multiplied by the number of periods in the year. Next, it asks for the present value, and that's the loan balance as of today. So we come up here to loan balance, hit enter, and the amortizing payment, there are 12 $80,523 payments each year. Now, you've probably noticed in both of these formulas that the references aren't cells, but they're actually named cells. And that's because when I went in and did formatting, you'll see here, for instance, let's look at this cell, B14. This is an unnamed cell. However, this cell here, which would otherwise be E4, I've renamed to be loan amount. And so if you were to do this yourself, and this isn't necessary, I like it because it helps me visualize on simple modules like this, doing or adding named cells helps me better visualize the formulas themselves. So if you wanted to do this yourself, let's grab a cell, this one for instance, J9. We just come up here, highlight J9, and here we'll call lender yield, must be all one word. And now this cell we can reference at any time. Let's say we put 10%. All we do here, we go equals lender yield, and it will output what is in that cell, right? So there we have amortizing payments. Next we have curtailment per period. Again, this is curtailment payments are additional payments to principal. And in this amortization table, we're going to assume that the borrower is making monthly curtailment payments. Now, I should say that including curtailment is not typical of an amortization table, but it's a fairly simple thing to add here, so I thought I'd include it as a feature. Next, we have payoff, and I'm going to come back to this. So for now, I'll just highlight this yellow. Then we have two inputs. These are origination fee as a percentage of loan and points as a percentage of loan. Both we'll call 1% for now. Now, something you'll have noticed is any of our input cells, these are our assumptions, those are blue. And this is real estate financial modeling best practices. In fact, it's financial modeling best practices. Blue font cells are input cells. Those are the cells that you as a user will be always changing. Black cells are calculation cells. You as the user don't change those. Now, if you're creating the model, of course, you're editing them. But once the formula is done and you're confident that it's correct, you don't change the black font cells. You'll also see in our models green font cells, which denotes references to calculations on other tabs. You'll also see orange font cells, which is a convention that we use exclusively at Adventures in CRE as far as I know, and those denote optional input cells. But here we're only going to be using blue font, input, black font, output cells. All right, the lender yield calculation will also come back to. So now that we have our assumptions completed, let's move into the actual table itself. Now the first thing we're going to build out is our period column. We'll just start with a 0. Time 0 is the period in which the loan closes. Think of it as the last day of the period before you have your first month. So if your loan payment is due on the 15th, then the loan, let's imagine, would have closed on the 15th of the previous month. That would be period 0. Here in this period 0, it's a custom row. We can't really copy down any formulas from this row, and there really are just a handful of formulas. We have a ending balance, which is equal to the original loan balance. All right, so we set that there. And then we have a lender cash flow. And the lender cash flow column, this is important to think about. From the perspective of the lender, is the cash flow an outflow or an inflow? If from the perspective of the lender it's an outflow, then it would be a negative value. And if it's an inflow, it's a positive value. So in this case, the one negative value will be what? Time 0 when the lender issues or lends out the loan balance minus any origination in points, such that the lender cash flow here is equal to what? The origination percentage plus points multiplied by the loan amount minus the loan amount. And in time zero, the lender will have an outflow of 14.7 million. 15 million minus whatever it earned in origination percentage and points. So that's our lender cash flow time zero. So now let's move to period one. And from here, the formulas that we write in this row will be dynamic such that we can copy those from row one down through the end of the amortization table. We're going to use here 360 periods, and our modeling will be done. So the formulas are quite complex so that we can avoid having to create multiple formulas beyond this row. So let's start with then our period one. This is equal to what? Well, because this is a dynamic table, and because in this case, right, we have a 10-year term, any periods beyond the 10-year term, we just want to be blank. Either we want them to be zero, or in this case here, I'm actually going to leave them as empty rows. And in Excel, an empty row is two quotation marks next to each other. All right, that leaves an empty cell or an empty row if it's in multiple cells. So we want to ask, should this row, or in this case, this particular cell, be empty, or should it output a value? And I'll be using some OR logic. So I go equals if, or the cell immediately above this is blank, or if the cell immediately above this is equal to the loan maturity date, which is the term multiplied by period, or if the cell immediately above this is actually, no, I'm sorry, if J15 here, if the previous ending balance of the previous period is equal to zero, meaning if the loan had just been paid off, if any of those things are true, so close parentheses on the OR logic statement, then we want just output a blank cell. Otherwise, we want to take the previous period and add 1 to it. And that gives us now period 1. Now, just to show you, and I won't do this for the rest to speed this along, but now I can copy this down. And you'll notice, look, all of these cells are down, but because, in this case, this cell here is 0, this is outputted as blank. But for instance, if there was a value here, now we would get a period for the next. So that is our period column. Next, we have beginning balance, and this is really simple. It's equal to the ending balance of the previous period. However, we need to do what? We need to say is if this cell is blank, then we want to leave the current cell blank. Otherwise, let's output the ending balance of the previous period. So payment. Well, we begin by just asking again, is the period cell blank? If it is, we want to leave this cell blank. Otherwise, what we want to output here is either an interest-only payment, an amortizing payment, or whatever payment amount would be required to pay off a beginning balance that's less than the required payment. And why is that necessary? Well, because we have curtailment here, there may be a situation where the beginning balance is actually less than the required payment. Thus, you would pay the lesser of the payoff or the required payment in that period. And what does that formula look like? Well, we go min of what? 16 plus any interest owed in this period. All right, that would be the payoff, Or what? Well, we'll output an IO payment if we're still within the interest-only period, or we'll output an amortizing payment if we're beyond the interest-only period. And to do that, we use Boolean logic. Now, if you're an accelerator member, you're familiar with this from the Anatomy of the Real Estate DCF course, where Boolean logic outputs either a true or a false, and in Excel, a true is equal to 1 and a false is equal to 0. And so if we multiply any value by Boolean logic that is true, the result will be the value that we multiplied that Boolean logic by. Otherwise, the result will be 0. So we go open parentheses, and we're just simply going to use some Boolean logic to ask, is B16 less than or equal to, open parentheses, the IO period multiplied by the total number of periods in the year, close parentheses, close parentheses. That's our Boolean logic. If we're within the IO period, that will be true. Otherwise, it will be false. We simply multiply that logic by our IO payment. And then we add that to what? Well, the same thing, but Boolean logic for if we're outside of the IO period. So we go open parentheses, ask, is the current period we're in greater than the IO in years multiplied by the number of periods in a year, close parentheses. Actually, I wanted those within their own parentheses. Okay, that's our Boolean logic, and we multiply that by an amortizing payment. Close those out, and now we have here an interest-only payment. However, if we were to set the interest-only period to, or the interest-only number of years to 0, well, we get an amortizing payment then. Okay. Next, we have the interest owed in this period, and that's a fairly simple one. So we go equals. First, ask, is this cell? Should this cell be blank? If not, then we simply take the beginning balance, we multiply it by the interest rate, and we divide that by the number of periods in the year. Close parentheses. 62,500. Now, again, we're in the interest-only period. Therefore, the payment should equal the interest. Next, we have the principal. And this does not include the payoff. I've separated that out into a separate column. So here, this is really simple. We go equals. Again, ask if this should be blank. If not, then we take whatever the payment that was made in this period, and we subtract any interest owed, and that will result in the principal from the mortgage payment. Next, we have the payoff. So at the end of the loan term, there'll be a balloon balance. The payoff is what is owed by the borrower at that point. And more than likely, the borrower will refinance this loan with a new loan and or sell the property to satisfy the balloon payment. And here, it's as simple as, again, first asking, should this be blank? If not, then we'll use some Boolean logic to ask, are we in the maturity period, which is current period equal to what? The loan term times the number of periods in the year. And if we are, then we multiply this by what? Beginning balance minus any principal paid from the payment minus any curtailment payments made in this period. Close that out. Right now we don't have a payoff, but if we were to set, let's say, period to 1, term to 1, we would then get a payoff of $15 million. Okay? So also that was a good air check to see that our the model is fully dynamic at this point. Next we have curtailment payments. And this here, again, we're going to ask, should this cell be blank? If not, we want to output either the curtailment payment required per this assumption. I say required, whatever the user has entered for curtailment period or curtailment amount in each period. The minimum of that or any principal owed, right? We don't want a curtailment period that is greater than the principal owed in, say, the final period that would pay this off because of curtailment. So maybe we're prior to the loan maturity, but because we're making these additional principal payments, the loan pays off early. We want this to be just the amount needed to pay it off. So that's a min, the curtailment amount, or the beginning balance minus any principal paid in this period. Close that out. And here we have a $50,000 curtailment. If we were to set this back to 0, it would go to 0. Okay, next we have lender cash flow. And here, okay, first let's make sure that this shouldn't be blank. Otherwise, what will the lender get in terms of cash flow? Well, interest plus principal plus the loan payoff plus any curtailment. That would be the lender's cash flow. So here in this first month, it would be curtailment and interest, $112,500. And then finally, we're almost done here. We enter our ending loan balance. And how is that calculated? Well, we go equals, and first make sure that this shouldn't be blank. Otherwise, what? Well, the ending balance is the beginning balance minus any principal minus any loan payoff minus any curtailment payments. Close that out. And we have now, because of the curtailment payment, an ending balance less than the beginning balance. Now, if we were to set this to 0, our curtailment, and that reverts to the beginning balance. And that's because we're within the interest-only period. Now, we're going to take these cells, copy the entire row from B16 through J16, and copy this down to the bottom. Alt-H-V-F to copy as formulas only. That way I don't lose my formatting. And if I scroll down, what we're going to see is what? Beginning of year 4, or after the end of year 3, the loan begins to amortize. And it will amortize through to the end of the loan term. Remember, 10 years, month 120, at which point there's $13,217,000 owed on the loan. The borrower makes a payment of $80,523. $55,000 of that is interest. So there's $25,000 in principal. You add that together with a loan payoff of $13,191,000, and that gets us $13,217,000, which in turn pays the loan off. Because this goes to 0, any subsequent periods are left blank, and we get a fully dynamic model. Now, we could set curtailment to 50,000 and watch what will happen. Now, again, it pays off. There's still a balloon balance at the end of the term, but it's substantially less because of the $50,000 a month curtailment. And even more, what if we went to 150,000? Now the loan pays off in month 80. And notice here, because we use that min formula, the curtailment is exactly equal to whatever is owed to pay off the loan in that one period. Now let's just finish up our top section by calculating the payoff at the end of loan maturity and the lender yield. So the payoff is a fairly simple one. It's whatever value is in this column here. Now there's an easy formula and a hard formula. I'm going to start with the easy one. Well, the payoff is simply the sum of the entire payoff column. And because we use Boolean logic to only output a value in one period, this will always be correct by using the sum. Now, in some cases, you may want a different formula. So here you might use index. And index is going to go and find one or more cells. So in this case, we just simply say, let's take the index of this entire section. And then it asks, what row number would we have here? And the row number is equal to what? The loan term times the number of periods, or in other words, row 120. and it outputs whatever value is 120 cells down within that index range. Okay, but I like that sum formula. We'll use that. It's a simple way to solve for our payoff at the end of year 10. Now, interestingly, right, if we go to here, payoff is 0 at the end of the loan maturity. Okay, we set that to 0, and then finally lender yield. Now, again, lender yield is basically the return that the lender makes on this investment, and that's simply the equals IRR of this column, close parentheses, and multiplied then by the number of periods per year, or 527. Now you might ask, why didn't I use XIRR? Lender yield is calculated with IRR multiplied by the number of periods, and you can prove that out by setting your origination and points to 0, and the lender yield is equal to the interest rate. But again, we go here, 1%, and the lender earns slightly more than the interest rate or the coupon rate. So with that, we have built a fully dynamic mortgage amortization table. Let me know if you have any questions. Use the comment section or the description below to find a link to download these files. And otherwise, thanks for your time today.